Hi everyone, it's me Vaishak. Welcome to my channel Simony. Today we are going to focus on scalars and vectors in kinematics. So let's begin with the definition of scalars and vectors. Scalars, they are quantities that have only magnitude. Example, mass, energy, temperature, and so on. And vectors, they have both magnitude and direction. Examples, displacement, velocity, force, weight, and so on. Temperature doesn't have a direction, right? It's just a numerical value. Weight, for example, is a vector. It is found by multiplying your mass with acceleration due to gravity, or W is equals to mg. And if you want to know what is the direction of the weight, just it is towards the center. I'm in India right now, and it'll be downward like this. But if the ground is transparent, and if you look the American guys, then their weight will be upward actually, right? Good. Now representation, mass, m is equals to 12 kilogram. Here you can see, you can either use capital M or small m, doesn't matter, and there will be a real number here and a unit, right? And velocity usually represented with the small or capital letters with the override arrow, and there will be a magnitude 50 meter per second, for example, and a direction e. And this e vector is called a unit vector, and we are going to discuss that one, right? Now, how to represent these vectors in one dimension? You know, a vector in one dimension has two possibilities for direction. Either it can be positive x direction or negative x direction. So here is an x-axis with the numbers denoted, and in this system, how to represent a vector? We will use this arrow mark for representing the vector. The arrow mark length will give you the magnitude, and the head will give you the direction. So you can count 1, 2, 3, that is the magnitude, and direction is represented by I cap. What is I cap? I cap is a unit vector in the positive x direction. And let's focus on another vector b. It has magnitude 4 and direction negative I cap. Negative I cap means it is directed towards negative x direction, right? Good. Now you got the idea of how to represent a vector. Now let's do some algebra. Simplest algebra is addition and subtraction. How to do the addition graphically? We had to use head to tail method. In this method, we'll be copying this A and also copying B and put them head to tail. That means head of A is attached to the tail of B. Now, to find the resultant vector, you have to draw a vector from the tail of A to the head of B. So, this yellow vector is actually the summation of these two vectors. So, C equal to A plus B equal to negative 1 I cap. And clearly, if you just copy this one, the result, and put it here, definitely it will have magnitude negative 1 and direction negative I cap, correct? So, that's exactly what is happening. Good, right? So this is the mathematical way of writing c equal to a plus b equal to negative 1 I cap. So in the case of subtraction, we have to use tail to tail method. So what is that tail to tail method? We are copying the two vectors and make them contact tail to tail. That's it. So you can see here d is equals to a minus b equal to 7 I cap is a mathematical way of writing. The same thing you can see in this diagram. To find the resultant vector when you're after you making them into contact in tail to tail mode, then you have to draw a vector from the head of B to the head of A. So that's what this vector, yellow vector, and you can see the length will be clearly 4 plus 3, and the direction is towards positive x direction. So this is exactly what we are getting with mathematical way of writing, correct? Now, mathematically, let me elaborate. A plus b equal to 3a plus negative 4 I cap. So That means you have to take these components and do the addition. So 3 plus minus 4 is 3 minus 4, which will give you negative 1 I cap as the result. Okay, and a minus b will be 3I minus minus 4I cap. So minus minus is plus, so resultant will be 7I cap. So these are the two methods, right? Good. Now, vectors in 2D is interesting because you can have infinite number of possibilities. In one dimension, there were only negative direction and positive direction. But here, in between 0 and 360-degree, you can have infinite number of possibilities for angle. So the graphical representation is almost similar to one dimension. You have an arrow mark and a head to show the magnitude and direction. The length will give you the magnitude and the head will give you the direction, right? And you can represent that direction using an angle theta. Okay, this theta can be running from 0 to 360, right? So to draw a vector, you need at least 2 points. Here I choose 1, 2, and 4, 3. 1, 2, and 4, 3. Now we will join these 2 points and draw the vector. That's it, very simple. Okay, let me copy this vector and draw it here. And this vector, have x component, basically x distance, and y distance, horizontal x distance and vertical y distance. Now in the triangle PQR, in this triangle, the length of PQ you can find using Pythagorean theorem. PQ is equal to square root of x square plus y square, which is exactly equal to the magnitude, because magnitude, is the length of the vector, right? So by knowing the points, I already said this point is 4 comma, what was it, 4 comma 3, and this was 1 comma 2, right? So a equal to square root of 4 minus 1 square plus 3 minus 2 square. So square root of 3 square plus 1 square, which will be square root of 10. That is the way of finding the magnitude. Now you may ask how to find the direction of this vector. We will just use tangent function. In the triangle PQR, tan theta is opposite side divided by adjacent side. So tan theta equal to y divided by x. So theta will be tan inverse y by x. So in this case, tan inverse 3 minus 2 divided by 4 minus 1, which is tan inverse 1 by 3. Very, very simple, right? Good. Now let's focus on the algebra of 2D vectors. Let's focus on the addition of 2D vector. We will use the same method as in the case of one dimension, the same method head to tail. So what we can do is we will draw two vectors a and b. Good. For addition, we will join the a vector to b vector in head to tail mode. So a vector, you copy it and you take another vector b without changing the direction and make them into contact like this. Good. See here, head of the A is connected to the tail of B, and to find the resultant vector, you have to draw a vector from tail of A to the head of B. Good. So that's what the sum of these two vectors, C equal to A plus B. We'll copy the same vectors. You can see the same vector is copied here and A also copied here, and you can see instead of head to tail, we are joining tail to tail. In the same case for one dimension, right? We took the A and we took the B and joined them tail to tail, right? To find A minus B, you have to draw a vector from B to the head of A, right? So the resultant vector D is equals to A minus B. Good. Now you may think, okay, how I can move these vectors from one place to another place? Vectors are coordinate independent. That means you can move any vector anywhere you want without changing the magnitude and direction. That means you can just, say like for example, mouse pointer in your computer, you can move it anywhere you want without changing. Its direction is not changing. It's magnitude, which is the length of the mouse pointer is not changing. So this is a vector. It's a constant vector, whether you move it this corner or that corner. Okay, right. So we can combine these two idea of addition and subtraction into single picture. Isn't that interesting? So here you can see the parallelogram law of addition and subtraction. So in this, both the addition and subtraction is represented beautifully. We have seen this a plus b using the head to tail method, right? And also we have seen a minus b, the tail to tail method. So this single picture will give you the idea of addition and subtraction. And don't think that always a minus b will be lesser compared to a plus b. Sometimes a minus b can be greater than a plus b, because this algebra of vectors depends upon the direction also, right? Now mathematically, how to do this addition and subtraction is rather easy actually. Let's say the first vector is ax I cap plus ay j cap, where ax and ay are known as x and y components of a vector, and b equal to bx I cap plus by j cap. Okay, first of all, what is I cap? We have seen this before in the case of one dimension. It's a unit vector in the direction of x-axis. That means it directed towards the positive x direction. Now, what is this new guy j cap? J cap is a unit vector in the positive y direction, right? There are two unit vectors. Their only purpose is to show the direction, okay? And they have magnitude 1. Both I cap and j cap have magnitude 1. That's why they are called unit vectors, right? Good. Now, a plus b, when you do that, you take these similar components. So ax plus bx, they are similar components because they have common I cap. And you do that, and next term ay plus by j cap, because ay and by, they are the similar components, just left of j cap, right? Now a minus b, to find a minus b, you do the same thing. Take the similar component and subtract and multiply with the unit vector. And here also ay minus by j cap. Okay, very good. To understand more about vector algebra, let's do a small example. In this example, a equal to 2i plus 3j cap and b equal to 4i minus 5k cap. We have to find the magnitude and direction of a, b, a plus b, and a minus b. So let's do basic calculations I taught you. Okay. So a equal to 2i plus 3j cap. Therefore, magnitude will be a equal to square root of x square plus y square, x component square plus y component square. So 2 square plus 3 square, which will be definitely square root of 4 plus 9, square root of 13, right? And direction will be theta equal to tan inverse whatever the y component divided by x component. That means 3 divided by 2. Good. Now b, we can find similarly, b equal to 4i cap minus 5k cap. Therefore, b magnitude will be square root of 4 square plus minus 5 square, which will be definitely 4 square is 16 and negative 5 square will be 25. So 16 plus 25, it will be 41. Good. And direction will be, let me write theta a and this as theta b to separate, So tan inverse y component divided by x component, so tan inverse 5 divided by 4. Good. Now, for finding the magnitude of a plus b and direction of a plus b, we have to find what is a plus b, right? So a plus b will be equal to, components wise, we have to add actually, right? So 2 plus 4 I cap minus whatever the y component here. Y component is 3 and negative 5. So plus 3 plus minus 5 j cap. So which is 6 I cap plus minus 2 j cap, or 6i cap minus 2j cap, right? So how to find the magnitude of this vector? Same method. Let me call this vector as D or C. C will be better. So C magnitude is just a C equal to square root of 6 square plus minus 2 square. So it will be 36 plus 4 square root of 40, right? Now A minus B, let me call that as D equal to A minus B, which is, you just have to subtract the common x terms and y terms. We have A as 2i cap plus 3j cap, so x component is 2, and x component for B is 4, so 2 minus 4 I cap, plus then subtract the y components, 3 minus 5 j cap. So the resultant will be negative 2 I cap plus 8 j cap. How to find the magnitude? D equal to square root of x component square plus y component square. So negative 2 square plus 8 square will be square root of 4 plus 64. So square root of 68. That will be the magnitude of A minus B. And direction I can call theta D. Oh, I forgot to find the direction of A plus B. Sorry for that. That will be theta C equal to tan inverse simply 6 divided by negative 2, which is tan inverse negative 3. Now theta D, that means direction of A minus B, is tan inverse 8 divided by negative 2, y component divided by x component, right? So it will be tan inverse negative 4. That's it. It's not that much hard, right? So analyze it and try to draw the vectors and see whether you are getting the same answer or not graphically. Okay, right. All right, students. So we have learned about scalars and vectors in depth. In the next video, I'll be doing more questions regarding the vectors. So stay tuned. Thanks for watching. Learn well. Bye bye. Take care.